Go on to 9.2, the area of circles and sectors. Who remembers the area formula? Yep, pi r squared. So can we use diameter in this one at all? No. But if they give me diameter, how do I find the radius? Yeah, divide by 2. Okay, calculate the exact and approximate area of a circle whose diameter is 24.8. So go ahead and try that on your paper real quick. Approximate it to the nearest hundredth. What'd you guys get for the exact area? Well, first off, what'd you get for the radius? Did you guys find the radius first? Yep, radius is 12.4, right? Because it's half the diameter. What did you guys get for the exact area? Remember, exact just means that I'm going to leave the symbol pi in because that's a non-terminating, non-repeating decimal that never ends. So anytime I would round it or use it, I'd have to round. So it's not exact. So what's your exact answer? Take a guess. It's okay if it's wrong. Perfect. 153.76 pi. Now, I'm assuming you guys were nervous to tell me that because it had a decimal in it. But is that decimal a terminating decimal? You guys know what terminating means? It ends, right? So when I took 12.4 and squared it, what happened was I got a terminating decimal. It's okay to have a decimal in that sense for an exact. It's just that I can't round. So that's why the pi is still there. What did you guys get for the approximate area then? That's 483.05, and there's my work on that. Very good. Find the length of the circle's diameter if its area is 361 pi. So area is equal to 361 pi. Isn't that equal to pi times radius squared, right? So what would I do first to start solving this guy? Can't take the square root first. Divide by pi on both sides first, yep. So now I get r squared equals 361. So then to get r squared down to just r, I would square root that. And what do you get for r? 19 is correct. Do they want radius? Nope, they want diameter. So what do I do to my radius? So what's 19 times 2? There you go. Good job. Remember yesterday how we were talking about arc length, and it was a certain angle measure of the entire circle, right? So there's a certain distance. It was finding like this piece right here, how long that was. Who remembers how I did that without looking back? Who remembers how you do that? Yeah.
It's the circumference formula, but you multiply it by the number of degrees.
Out of?
2 pi r times the number of degrees
Over 360, right? So it's your fraction of 360 that takes up. Well, what we're going to talk about today goes along with area, okay? So here, we're talking about area of the entire circle. So the area of the entire circle is the amount of space it takes up, right? But now we're going to talk about area of a sector. Area of a sector means like the piece of the pie that you're going to eat. So it wants like the area of that little piece. Knowing what we did yesterday, how do you think you're going to do this one today? What do you think the formula is for this? Awesome. Yeah, it's the same thing. It's your area formula, though, this time. So pi r squared times the number of degrees it takes up out of 360. Does that make sense? So let's say that this radius is 6, and this takes up 50 degrees. Go ahead and solve the amount of space that piece of the pie takes up out of the total. Go ahead and find the exact. Or, I'm sorry, find the approximate. What'd you guys get? Yep. And I just went to the next decimal, so 7-1. Very good. And then we don't have units. So it would just be units squared because it's area, right? Any questions on that? Okay, next page. Go ahead and try number 3 and number 4 on your own. Try 3 and 4 on your own. Okay, calculate the area of the shaded region. They gave us the number of degrees in the non-shaded region though, right? So how many degrees would be in the shaded region? 240. So pi times 4 squared times 240 out of 360. You could have found the area of the circle and then subtracted off the area of this non-shaded area and then gotten the shaded area, or you can just do it this way. Did you guys pick up on that or not? Okay. What do we get for an answer? Rounded to the nearest, let's do 100th. I don't know, is that what you guys rounded to or not? What did you guys get? 43? 33.51. And then this would be centimeters squared for my units. The shaded region below has an area of 54 pi. Solve for the number of degrees. So we know pi. We know that the radius squared. What we don't know is the x out of 360. But we do know that that equals what? 54 pi. What'd you guys do? Divide by pi first. So that canceled out pi. So I'm left with 12 squared times x over 360 equals 54. What do y'all do next? How do we start getting x by itself? Did you multiply by 360 first? I guess I can do that, right? Yeah, I could do that. Multiply by 360 on both sides, so I get 12 squared times x equals, what's 54 times 360? It's going to be a big number, it's okay. 19.4. Okay. That's not what you had to do next. I would have done 54 divided by 12 squared, which would give me some funky decimal, and then multiply by 360, but the same, that's, either one works. What do you do now to get x by itself? What is 12 squared? Isn't that 144, right? Divide by 12 squared, which is 144. What do you get for x? 135. This is an angle measure, right? So it's degrees. And we know that it has to be somewhere in between 0 and 360. Does that look like it could be 135 degree angle measure? Yeah. Okay, I want you to try 5, A, B, and C on your own real quick. 5, A, B, and C. All of us who are confused on where to go here, we can kind of get a place value or placement. First question is the measure of P to Q. They're actually asking for this angle measure when they say it like that. Okay. Multiple ways to do this. What is one way that you guys did it? And we'll go through that way, and then we'll go through another way after that. Someone tell me what they did. Yeah.
I did the ratio of the area, so I did 55 over 295.52.
Mm-hmm.
And that gave me a decimal. I multiplied that by 360.
So essentially, you set up a proportion and solve for. Essentially, you set up a proportion and solve for how many degrees. So this little piece, they're saying it has an area of 55 out of the total 295.52. Well, we want to know how many degrees that takes up out of the total 360. So when you do that, we cross multiply and divide. What did you get for the number of degrees? 67 degrees. Now, if you did it a different way, you should still get that same angle measure. Knowing that, we can now work backwards and find the radius, right? So we know that, what do we know? We know 55 over 360. No? Yes? Help me out. Why am I blanking? Yeah. Times pi r squared equals how much? 67 degrees? Is that right? Do I have that backwards? 67 here. 55 here. Right? Yes. Sorry. There it is. Sorry, guys. Correct? Okay. When I do that, I do it like I did last time. I'm going to divide by pi. 55 divided by pi. I'm going to leave all this in my calculator because they're going to give me some messed up decimals. And then I am going to multiply by 360, but then divide by 67. And then I'm going to square root that. So essentially what I did was I multiplied by 360 on both sides to get rid of the 360. Then I divided by the 67 on both sides. That left me with pi r squared equals some funky number. It was around, or I had already divided by pi. That left me with r squared equals 90. It was 90 something. Then what I did was I square rooted that. Are you guys following it all or not? Okay. Do you like how I wrote 90 something? And then whenever I square rooted that, I got the radius is 9.7. Do you guys agree or disagree? Okay. 9.7. This is 67 degrees. Okay. Now they want the arc length of P to Q. How do I find the arc length of P to Q? So we're going back to length, distance around. Is that area? No, what is that? Circumference. What was the circumference formula? 2 times pi times radius. And in that case, our radius is this, right? But that gives me the whole distance around the circle. Do I want the whole distance around the circle? I just want that section, so I multiply it by what? 67 over 360, the part that it takes up out of the whole. So I type all that in my calculator. What do you guys get? Rounded to the nearest hundredth. I got 11.34 also. Did someone get something else that we need to go over? And that would be inches. This is inches. That's degrees up there. I think I completely confused you with this part though. So going back, did you guys understand how to find the 67 degrees by setting up the proportion? How much they said that they have of the area out of the total area equals the number of degrees out of the total degrees. So part over total equals part over total. Cross multiply, divide, and I get 67 degrees for in there. Easiest way to find the radius is use the area formula, 295.52, and set that equal to pi r squared and solve for my radius r, which turns out to be 9.7. Then we know all the information to find the arc length of P to Q. So this is arc length. This is number of degrees in that piece. Okay? is just to finish that first page in your supplemental packet that goes over the information from yesterday.
Maybe you would